All right, guys, here we go. Let's see how this works out. Uh, let's kind of look at this here. Hopefully, you guys can hear me. If not, we'll just make it work. Uh, we are looking at chapter 4. This is the pretest. This is the pretest. And we're looking at, they talk about this is an experiment here. And then they ask you, what can you conclude about this? Let me do a different color than that. There we go. You can remedy is effective for treatment. Remember, for it to be effective, it has to be there has to be a control. Okay, so you've got to compare it against something. We don't know about sample size just yet. This is just a statement without anything, so that one won't work. Uh, Another statement without any pieces of information. So, really, what we can conclude is that there's nothing because we have no control group for comparison. So, remember when we're drawing a sample size of 5, so we're drawing 5 numbers without replacement. So, once we draw a number, we can't use it again. And the households are numbered 0 to 1. They tell you right here 0 to 2, all the way to 50. So, we're looking for two digits. And they're going to start you with this random number line. So they give you the random number line. So 11, that one works. 36, that one works. 23, that one works. 8. So then 69 doesn't work. 29 works. What happened? 23, what did I do? Oh, 56 doesn't work. 92 doesn't work. 96 doesn't work. 23 doesn't work because I've already used it. 79 doesn't work. 08 does work. And 42 works. Now I've got a sample of 5. 1, 2, 3, 4, 5. Remember, without replacement means I can't use 23. And if it's a household of a size of 50, anything over 50 doesn't work. So that's why that's the answer. All right, so next here. Next, we've got sorry, my wife was texting me, guys. A research company has contracted 60 families, each with 2 children, who have agreed to test the product. He randomly assigns 30 families to the group that will use the new formula and 30 to the group that will use the company's detergent. All right, so the most important reason for the random assignment is, the answer is randomization is a good way to create 2 groups of 30 families as similar as possible and the comparisons between the 2 groups. So the idea of creating groups as similar as possible is the key piece. When you do that, you limit all the lurking, you limit all the confounding, you limit all that stuff, okay? It's not a double blind. It reduces the impact. So when you create groups as similar as possible due to random assignment, it limits all that other stuff, okay? All right, so to test the effect of music on the productivity, a group of assembly line workers are given MP3 players. This is where I need a new book so I can update. MP3 players are now on your phone to play whatever music they choose while working for a month. For 1 month, they work without music. The order of 2 treatments for each worker is determined randomly. So basically, the idea is that you are taking 2 treatments and you are going to apply it to each worker. So you're attaching a pair of treatments. So that is going to be a match pair design. Okay. All right. A nutritionist wants to study the effect of storage time. Okay. So as we look at this, the treatment is what is applied, the experiment unit is what it is applied to, and the response is what they get out of it. So let's look at this. So what's the treatment? Study the effect of storage time. The effect is the treatment. They're going to treat it for 6, 12, and 18 months. On the amount of vitamin C. So this is the explanatory, and this is the response. Oops, response. I can't spell right now. So this is the response. So that's the response right there, and that is the treatment. And then what are they applying it to? They are applying it to the fruit packs. So there it is right there. Okay. Remember, the treatment is what they apply it to, what they apply, and it's usually explanatory. The response is what you're looking for, and then whatever they apply the explanatory or the treatment to is going to be your experimental unit. All right, a sample student opinion selects a SRS of 200 of 30,000 graduate students and a sample SRS of 5,000 graduate students. This kind of sample is called a stratified because why is it called, oops, I didn't mean to do that. Why is it called a stratified? Because they created two specific groups of like characteristics that is as similar as possible. So graduate students and undergraduate students, okay? Researcher observes that on average, the number of divorces in cities with Major League Baseball teams is larger than in cities without Major League Baseball teams. The most plausible explanation for this observed association is the association is presence to the lurking variable because Major League Baseballs tend to be in larger cities, okay? So why are the other ones not correct? The presence of Major League Baseball team causes divorces to rise. Perhaps. The word perhaps, that just kills it right there. Spending too much time. You would actually, the word cause means you need an experiment, okay? So that's automatically wrong if it's not an experiment, okay? The high number of divorces is responsible for the presence of a Major League Baseball team. Now think about that. That means the higher the number of divorces, Major League Baseball teams are going to move there. Okay, so the word responsible means you have to have an experiment. There's no experiment being done. Association makes no sense since many married couples go to the ballpark together. That's a possibility, but we don't know that by the information that we're given. We don't know that. Observed association is purely coincidental. It is implausible to believe that the observed association could be other than accidental. Again, we don't know if it's purely coincidental. It is implausible to believe. You need the word implausible. That doesn't count for anything. You would need an experiment to make sure for that one. Okay? So the only one here is association is due to the presence of a lurking variable. That was a little tougher question on these. This is vocabulary driven, guys. So, okay, survey is to be administered. So we're talking about a survey for a random sample of students. 3 variables are recorded. The gender, the starting salary, and the area of specialization. Which of the following best describes a conclusion that can be drawn from this study? So the idea is that we can only associate it with the gender, the starting salary of graduates among that nursing school and only that nursing school. Okay. Because they're at a certain, when you see a certain nursing school, your answer has to be only about a nursing school. Okay. And since we have the word cause in things, that means it had to be an experiment. So watch yourself on that. The word cause means it has to be an experiment. Okay, bias is present in the following sample designs, each one. So we're looking for, okay, now this is where you have to really be specific about what you're talking about. So I'm going to go to a different color. I'm going to go to the green. The wording of the question. Do you disagree Americans should preserve their constitutional right to preserve constitutional right? That is front loading the question because they're implementing that they're taking away your constitutional right. And so you got to watch the wording of the question. It pushes people to agree, and it's going to make them be higher than the actual value in the population. Okay, so because they're opposing gun control, they're trying to load the question. So instead of saying, "Do you oppose gun control?" that's not what they're asking. So they're looking for a result that's higher than they need. Okay, a flour company wants to know that local households bake at least twice a week. A company representative calls the households during the daytime. That's the key piece, and finds that 50% of those who respond bake at least twice a week. Non-response would be a problem because there's people at work or they're too busy to bake. So if they're baking, that means they're home and they're probably bakers. Then more than likely it's going to be higher. We got to watch out for the people that are at work, and the people. These people that will also not be home during the daytime to answer the survey. So it's going to be, so we're leaving out people, plus we're surveying people that more than likely have the time to bake. So it's going to be higher than the actual population. Okay. All right, number 10. Describe how researchers would randomly assign volunteers to the 4 treatments. Okay, so here's the key piece to this, guys. This is kind of the name in the hat kind of idea. You can do it multiple different ways, but notice how they use note cards. Then they did 25 apple slices. Then they did 25 applesauce. Then they did 25 apple juice. Then they did, let's see this one, 25 juice fibers. Then here's the key piece. They shuffled the cards and distributed them one at a time to the volunteers. So everybody was random. So you can do this also. Label 25 pieces of paper with apple slices, 25 applesauce, 25 apple juice, 25 apple juice with fiber. Put them in a hat, shake them around, and then draw one at a time to the 100 volunteers. Okay? So same idea. You can use note cards, hat, anything you can say. Suppose that the reduction of calories was determined to be statistically significant. Explain what statistically significant means. Okay, so here's the big thing on this one. This is a little tougher. That means, let me do the highlighter on this one, guys. So the idea of this is that the reduction in calories was not due to us being random. It was far enough away. Another way to look at it is it was not due to random chance. Okay? So that means that if we kept doing this randomly, we'd get the same answer. So the reduction would be determined. The reduction in calories would always not land in the random chance area. How might you incorporate blocking into the study? There's a couple of different answers you could do, but since we're talking about calories, bigger people may eat more calories naturally because they burn more calories. So you wouldn't want them in this treatment group. So you could take the 4 heaviest people and then assign each of the 4 treatments. So remember, the whole key to blocking is to create similar individuals. Okay? To block is to create similar individuals depending on what you're doing. All right, 11. So was this an experiment or an observational study? So if you're looking through this, you're going to find out that they did not impose a treatment. So that means it was an observational study and it was based on the choices of the subject right there. So really look, if it's an experiment, they're going to be applying a factor. The research only used men. So one statistical benefit is that if men and women reacted differently, this could be totally, there's a random, not random, but there are multiple different answers here. Just know that you'd have to be able to explain it. So this one they talk about men and women react differently to fish, and so therefore, if they did, that means there would be more variability in the answer, and so only men eliminates that variability. Okay, that's one benefit. The drawback usually is that seafood can only have an effect on men, so we can only talk about men. We can't apply it to women. Okay, so we get a benefit that if there's a difference between men and women, that variability is not in there. But on the same hand, we can't talk about women when it comes to fish. You can only talk about the men. Okay, so explain the meaning of confounders in the context of the passage above. So when we're talking about, we're all the way back up here. Okay, so remember, we're looking for a lurking variable. Variables such as smoking and red meat are called confounders. Here it is. You have to state what they mean, because it is possible that the group eats more fish and smokes less and eats less meat than the group that eats less fish. Okay. So the idea is that any of these variables can reduce cancer risk. They don't know which one it is. So all of a sudden, the lurking variables become confounders because we can't separate the fish, the red meat, and the smoking out at the end. So since we can't eliminate them at the end, that means there's no possibility that their variability. Sorry, let me rephrase that. There's no way to tell that they're not involved in the response variable, so therefore they're confounders because it could be one or the other. In a new study on this topic was being planned, explain what researchers could do to reduce the source of variability of unknown confounders. Okay, so now we're looking at how can you create a better experiment. You could literally assign half of them to eat fish and the other half a non-fishy diet. And that could balance out the effect of smoking and all those different things. So, because the idea would be that if you had a fish diet and a non-fish, your hope would be to get a red meat eater here and a red meat eater here and a smoker here and a smoker here. So that's what they mean by being able to reduce possibilities. You're trying to create where we balance out the lurking variables that became confounders up here. So this answer stacks on this one right here. I know it's a big vocabulary driven system right now. So here we go. That is it, guys.